Imperva, a Thales company, is the cybersecurity leader that helps organizations protect critical applications, APIs, and data anywhere, at scale, and with the highest ROI. With an integrated approach combining edge, application security, and data security, Imperva protects companies through all stages of their digital journey. Imperva Threat Research and their global intelligence community enable Imperva to stay ahead of the threat landscape and seamlessly integrate the latest security, privacy, and compliance expertise into their solutions. Start a free trial today at securityweekly.com/Imperva. Welcome back to Application Security Weekly. We just talked with Melinda Marks about software supply studies and how companies use tons of tools, still have tons of challenges, and still need to scale their AppSec solutions, including a little bit of modern AppSec and some Gen AI. It was a great, fun conversation. I'm your host, Mike Shima. I'm here with John Kinsella and Paul Asadorian. But first, before we get into the news, two quick announcements. On the evening of Monday, May 6th, W2 Communications and Cyber Risk Alliance are bringing Cyber Tacos back to San Francisco. Get free food and drinks as you mingle. Just mingle. Don't worry about just think of tacos with cyber professionals from all over the world as they descend on RSA. The point of this announcement is to register your spot at securityweekly.com/cybertacos. And the other announcement that I'm going to try to get out in one breath is to join the digital identity community at the Aria Resort and Casino in Las Vegas, May 28th to 31st. The 15th annual Identiverse will bring together over 3,000 security professionals for 4 days of world-class learning, engagement, and entertainment. As a community member, receive 25% off your Identiverse 2024 tickets using code IDV24-SW25. You can just skip everything and go to securityweekly.com/IDV2024. And man, I'm getting tongue-tied today. I don't know what it is. It's probably because all I did was look at the same old vulnerabilities that we see every week. So John and Paul, you're going to have to help me out to find something fun and different here. So I will start with kind of generic types of vulns, but in an article that's well written and walks the reader through how they found things, is this sharing data leak vulnerability. So I don't think it's a location tracking, like a parental control app for iOS and Android. Not necessarily very exciting. Not a huge, it supposedly has 35 million users, so perhaps it's huge from that perspective. But it's just nice that it walks through using, essentially, it's something like Z-Attack Proxy, a tool we love here, about intercepting the HTTP requests, tweaking them, playing around with them, looking at some UIDs in the authorization header to go and see other people's data. So I'm running through it kind of quickly because it's actually a nice read. So that's what I wanted to highlight on that. If you want to read about web app hacking, this is a great type of article for it.
Yeah, it's I found it interesting that he reached out to, so part of this is he was trying to contact the vendor and go, hey, you've got a problem. He reached out to a journalist over at TechCrunch. And I think even though I'm quite familiar with TechCrunch and Zach Whitaker, you don't think of, so TechCrunch, for those who don't know, it's a publication focused on the startup community and, mostly Silicon Valley, but around the world. And you don't think of them having a pretty great journalist who focuses on security.
But they do.
Probably speaks better than I do, and Mike too.
Yeah, he's really good.
Yeah,
His
he's great.
newsletter's awesome too. Yeah.
And so it's just like it's not something I expect to see at the beginning of a write-up, but kudos for him to reach out to that guy instead of, I don't know who else you'd reach out to, but yeah, I don't know if you had more share on it, Paul. I'm just babbling at this point.
Is it send the credentials in clear text? Is that what I'm reading in the top of the article?
Well, it's more about the authorization header. So, these are types of things, as with any API, how do you authenticate to that API? And is it going to be a hard-coded credential that we hope never to see within these apps? Or is it going to be your raw password or an API key that's on a per-user basis? Or even better, is it a signed request? And we talked a little bit about this, I think, either last week or the week before, in the sense that a signed request doesn't expose the raw secret, the raw credential on the wire. It's just proving that you have possession or knowledge of it. So different ways to do that, which I think is a good question because it sets me up for another one about a Let's go back to the 90s. This Crush FTP, which was created, I think, back in 1998, still an app that lives to this day. So kudos to them. And it had some vulns, but when I was reading the CVE, the thing that stood out to me is that the default configuration uses reversible DES encryption for passwords. That just sounds, that sounds very 90s, actually. And so it made me think, why do we still have software that has these types of defaults? And it is a little bit of the repetition that I put in here about secure by design, secure by default that CISA's pushing on. But John, I love to talk about refactoring and re-architecting apps, but at what point do you just say, let's get rid of DES for storing passwords?
Hit the eject button.
Thing. Yeah.
I don't know, man. Yeah, I'm with you, and I think there'll be at least one more article in here around this concept of how long do you use a library, or how long, when do you pick which library? Maybe I guess the question for me becomes, I didn't look at this too closely. Did they know they were using DES? Had they ever heard of triple DES? Or were they just using some library which said, let me go and encrypt this for me? And, that's good enough because, we're encrypted and that's science. So, yeah, I don't know. And, you could go the whole way up on this and talk about refactoring, like maybe you refactor out of using FTP. I know it's still popular. I know there's reasons it gets used out there. But yeah, I don't know.
Yeah, it seems to me like companies don't often go back and reevaluate the code for even semi-modern security vulnerabilities. And what I thought was interesting about this one was it was patched the same day it was disclosed. So this was a pretty easy thing, like operational risk, ease of patch. Seemed pretty easy for the company if they did it in the same day. It's like, why wouldn't you just go look for those and fix it in your normal cycle, right? They waited till an external party identified the vulnerability. And I think that's one thing we need to push for change, right? Is going and finding and fixing on your own. Yeah.
And this was also an echo to last week we covered Putty. And Putty SSH, they had a vuln because, the 521 bits is 9 more than 512. When that's a little bit of the summary of where the flaw stemmed from. But is that idea that you pointed out, Paul, is that it was a great decision at the time. It just so happens that as key sizes got bigger, that secure design became insecure. So surprise, we do need to actually pay attention to software as it lives and thrives within whatever community we have. But speaking of living and thriving, John, I think you were already setting this up too. You've got an article about I'll read the headline, an abandoned buggy PHP encryption library gets forked. And the abandoned and buggy might be redundant, but I don't want to pick on PHP too much.
Well, this is a PHP library, so it's I won't pick on PHP for this one in particular. There's a library out there called PHP ECC library. As you can probably guess, it's for doing elliptic curve encryption. And the last commit on their GitHub, I think I closed the window, but it's about 4 years ago. And some folks let's see, these are from, I think their name might be hidden, Paragon Initiative Enterprises Security. And some group out there said, hey, we found this weakness in there in how they were computing the curve. And they submit an issue to hey, we should probably fix this. Your encryption is broken. No response. And there's a few other tickets out there with no response. So they went ahead and forked it. So the latest issue, if you go over to the GitHub, is, hey, we forked it. Go look over in there instead. Okay, that's there. That happens. It's an unfortunate part, right? Any of us have done open source stuff. At some point, you get tired of it. Don't look at mine. I'm positive there's stuff there, which I said I'd update every few weeks, and it's been years. It's just the nature of it, especially when it's an individual or only a few people working on it. But the problem to me now becomes, as Melinda was talking about, SBOMs and stuff like that the last half, along with Paul. Now you're at the point of which one of these two libraries do I use?
Yep.
So that's to me is okay, well, we've already, we're just talking about okay, well, they're using DES, not triple DES. Well, maybe they should be using something else. Now it's okay, which library should they be using? And what Paul said, it was a nice, simple one-day fix is next thing you know, you're spending 2 or 3 days just trying to figure off the internet which one of these libraries you're supposed to be using. So that's the tough part of this.
Yeah, it hits on my soapbox, right? I presented at B-Sides Charm, and I asked the audience, I said, do we all agree that if there's software that exists in its whatever version of that software, and it has a vulnerability, we should issue a CVE. Everyone's like, yeah, like that's a good idea. We need this tracking, right? And this is a situation where I'm not sure if a CVE was assigned or not. But the challenge, John, to your point is, as a software developer, how do I deal with this? How do I know that I need to switch libraries, right? Is CVE the indicator? Is there some other software, right? I'm sure commercial vendors have this built in that goes, well, you're using this library and it's vulnerable, therefore you need to switch to this other one, which shouldn't really be that, in my assessment of this, right? Probably not a big deal for most PHP developers, but it's the knowing of that, right? It's that trigger that a software developer needs to make a change because something, and this is a tricky situation. Something was abandoned, new project was created. I gotta switch, right? I just don't need to update the version. I gotta switch.
Yeah. And good call out on CV. So looking at their post, we have requested a CVE identifier from MITRE for the ECDSA weakness. And to date, looks like 5 days ago, no ID has been assigned. And I know MITRE's moving slower than the others. That's why GitHub and everyone else has their own numbering authority. But and now the next question comes like, okay, you got a CVE ID. Do you assign it to this old project, which has the bug? Or since you're the new project and you're actually going to patch that bug, do you send it to yours? Because now you're like, well, we already have a CVE against this, and some people go think that's bad.
So. Yeah, that's a good question. Like the original fork would contain the vulnerability, and then there'd be a pull request and a version increase to fix that vulnerability. So does it affect both, right? Does a CPE affect both?
Yeah, and that's where also too, even with the CVE, do I care? Because there's a lot of CVEs out there about like a regular expression DOS. That's one of those categories that somebody made, a decade ago. Made a DEF CON, a Black Hat presentation, and it was now the new cool thing to find. So a lot of bug bounty researchers, a lot of others went out and find these vulns. Some of them can be impactful, but so many times it's just a CVE that's like, yeah, okay, I'll shrug and it's a bug to fix, but it's not going to make me switch libraries, or it's not going to be something that's just because the CVE is there, and even the CVSS score, that severity isn't always something I'm going to agree with. So that's one of those dangers. I'm going to expand this a little bit too now, because there was that CVE about the crush FTP. And it was one of the other things about that is that it was also allowed unauthenticated arbitrary file read as root. And so that just sounds like, wait, why is our software architecture allowing this? How do we not have restrictions here? Which is a little bit similar. I'm going to pull into an article about SourceForge that patched a critical code vulnerability that some researchers at Sonar found. And there was also, in fact, a file read vulnerability that could pull out the signing key that's used to sign sessions. And if you have that signing key, you can create your own session, which ostensibly you could impersonate someone else, or as they discovered, skip right ahead to a serialization attack. And it just so happens to be a serialized, validly signed request. So pretty cool discovery. This was done by researchers. SourceForge, if it's still being used, they throw a little bit of shade at it at the beginning, but it's SourceForge, GitHub, GitLab, these types of source code and package repositories are moving towards like MFA security. As you were mentioning, Paul, like there's an expectation, should we have a CVE for this? What about raising the bar? Like what are our expectations for bits of our supply chain, these platforms that are quite often for free, but still have to have security to them?
Yeah, it's interesting. I was listening to the Open Source Security podcast, great show, and they were talking about how like if there's a vulnerability in GitHub, everyone has a vulnerability, right? And I think when we get down to some of these packaging systems, distribution platforms, a vulnerability in that platform affects all the software, right, that's packaged with that. And it's a huge concern for me, right? Being a Linux user, I rely on not just the software being secure and patched and updated, but the packaging and distribution process is a critical point where attackers are going to go after that because, hey, I don't have to leverage a software vulnerability necessarily, maybe to get in, but then I can backdoor that software like we saw with XZ, right? And attacking those packaging mechanisms is a great concern. of mine.
And that's where I also pulled in an article about that usually I just read and move on, completely ignore. That here, this week, there's a list of 19 NPM packages found with malware. And sometimes it'll happen over Pippy. It's like, okay, fine. It's a number. It's a bunch of packages, blah, blah, blah. But the reason I actually highlighted it this week kind of echoes what you were saying in the sense of why or how did that malware get in there? If NPM, for example, is requiring MFA, was this a different type of account takeover? Was this a user account that actually hadn't migrated to MFA because it didn't reach a threshold of users or criticality? Or was there something else where, it was a malicious maintainer or something like that? And I think knowing how the malware got into there is more interesting to me in terms of finding a solution, preventing, rather than just saying this week is 19, next week is going to be 23, the week after that it's going to be some other prime number, and maybe we'll find a pattern in numerology, and that will be something interesting. But otherwise, it makes me snooze.
Yeah, we can only do so much to secure the people that are producing the software that we use, right? I mean, we can put a lot of measures like MFA in place, but someone could be a good developer one day and then be a malicious developer the next day, or slowly over time. So I think we just have to expect that there has to be other checks and balances to say, is this software in this update good or bad? And that's where I think the really interesting research in our field is today in software supply chain security. XZ was a great example of that. How do I know that something's been backdoored? Like, is this update good or bad? If we had a perfect way to detect that, man, your startup would be doing really well right now, right? But it's a hard problem to solve.
I mean, really,
indeed.
On this one too, back on the source code part of it. Do we know that they haven't been compromised? I mean, okay, this researcher found this. Do we know that no one else is? And I'm scanning through the article and I don't see anything around that. So, I mean, and I think sort of, we were snarky. I was snarky myself about SourceForge still existing. And hey, cool, they open sourced the system behind it so, others can see the code and do stuff like this. But, and I think developers and publishers are going back to SourceForge so they're not on GitHub for whatever reason, if you like or don't like GitHub. But yeah, is if you got this many packages out there, how do you know that this hasn't been exploited? A little worrying.
It is an excellent question, which I do not have an answer for. Therefore, I'm going to continue on so I don't have to pretend. But speaking of things that speaking of MFA and credentials, we could just make passwords illegal, or at least a certain set of passwords. And this was an article that you've got, John.
Yeah. So the UK government has passed a law which let's see if I get the actual wording in here. I'm not going to send people to the actual law itself, but basically they're saying 3 main requirements all smart devices must adhere to: shipping devices with easily crackable. Wait, I'm reading too much from the article. They basically were making the password. They're saying that it has to be complex, unique, can't be a simple default password. I get it. Respectable. Sounds great. I don't know how they're going to enforce that, but I guess we'll see. But the other part of it for me, I think particularly amongst the three of us, this is really going to resonate. How often do you either like pull something out of a closet, or you buy something off eBay, or however you get your hands on this thing and you're like, well, I need to reset it so I can get on my network and use it. What's the default password? Let me go look on Google. What do you do with this? I was going to make a comment in the show notes of like, make sure you Sharpie your password onto your devices. Like, that's not the best idea. So yeah, I don't know. I see it. I like I like the thought behind it. But yeah, I guess if you have like a reset button, so there has to be some other way that hopefully the publishers or companies will start thinking about of how, if someone loses that password, this device is not just bricked.
Yeah. And some of the things I've seen are just,
right?
Yeah. And you can have a default password that's uniquely generated, printed on the device. That's going to be that is a cost. So there's a marginal cost there, right? Or a QR code that you scan, but that also presumes then that QR code is going to resolve to a website that is going to stick around while that company lives. And we've probably seen, I think, more than a few companies go away while their hardware still exists.
Yeah, I think for me, it's that shared responsibility. Like, whose responsibility is it to solve this problem? Is it more on the manufacturer side or is it on the consumer side? And what we often find is that there's some shared responsibility. I think on the vendor side, they can do better in providing better mechanisms, better authentication to your devices. But on the consumer or enterprise side, if you're consuming this stuff, you also have to go look for it yourself. Like, I'm a huge proponent of attack surface management, pen testing as a service. You need to go discover these things in your environment. And if they are configured or have known exploitable vulnerabilities, you should find those on your own as well.
For me, it comes down to the idea that centralizing towards the manufacturer is going to scale better. Why have the manufacturer shift all of that responsibility, that burden onto the user, instead of just making a nice secure default? Because there are ways of solving this. It just so happens that those ways require engineering time. Basically, they require money. So it's going to get passed on to the consumer in one way or another. But that feels, to me, the better solution. You were also mentioning, we've talked about GitHub, GitLab, SourceForge, leaked secrets. I mentioned back in our discussion with Melinda, rather than having a whole bunch of different tools to go find, my source code, did I accidentally hard code some secrets? It can be helpful for each of these repos, these platforms, to be scanning all of the code that gets updated, pushed to their platform, and find those secrets. And then, as GitHub, for example, does, it can even go talk to Amazon or a couple of the other vendors and say, it just so happens we found a secret that's used on your API. Do you want to revoke it? That, to me, sounds like a great way to centralize and solve that sort of problem.
Yeah, I agree with you, Mike. It's better to solve it at the macro level, similar to the way we had a guest on that talked about how Microsoft Windows is a shining example. Microsoft fixed a lot of security vulnerabilities by just making people auto-update and apply patches, right? That was a global, everyone got more secure, right? And if you leave it to the end consumer or enterprise, it's going to be very spotty. So I think these efforts are good. The UK PSTI Act seems very similar to the EU CRA in requiring manufacturers and vendors to have a higher level of security before goods are brought into that country. So
the tough part on this is, think about the Microsoft example. That's expensive. Imagine how much Microsoft has to spend every Patch Tuesday. And now with cloud, they can spin stuff up and take it down. But still, how much does it cost to provide both the servers and the bandwidth for however many millions of these systems to download a bunch of patches? I'm guessing it's got to be in the millions a month. And again, that's a larger thing. It has adoption, and so there's revenue there and all that type of thing. And the business side is justified. But for a smaller company or like someone who's just making something cheap and getting it out there, a little more difficult to do. So.
Absolutely. And I think Microsoft was even charging, after Windows XP's lifetime, they still then, for those of you who still refuse, if you just so happen to be, small things like ATMs, healthcare providers, if you still happen to be using Windows XP, you can pay for some extra extended support just because you don't want it to go away. So not proposing that as a revenue generation mechanism to just let your software go die and people still want to use it. But speaking of in the consumer world, so that story about the UK bad default passwords make them illegal, that's very consumer focused, consumer oriented. Also in the consumer world is AV software. And here's where probably, as you mentioned in the show notes, John, Paul and I will probably just be like, okay, keep on moving. AV, a little bit of a yawn. That's my stage yawn. But John, tell us why we should be interested in this article.
So this is one to put a smile on my face. It's antivirus software in 2024 that was doing its updates over HTTP. You can guess what happened. So some fine folks on the I'll say the underworld, but some malicious folks out there realized, hey, we can use this for our own advantage and use it as a way to do man-in-the-middle attacks and go ahead and deploy malware out to these systems and use it for a distribution network. So that's it, right? That's the good giggle, good haha. The write-up's actually really good. It goes through in sort of detail about what's going on and what happened and why, and makes you, it's for those of us out there who are always trying to improve one way or another. It's good to go through and read this and go, okay, that's what happened. How did they do that? They had to get access to DNS, find the file you want to put in there, figure out how do you get man in the middle. So it's not just quite as simple as our eye rolling is making it out to be, but still it's please don't do this. 10 years ago. But if you're going to do it, here's a good write-up of what happens when you do. So, and that's about all it deserves.
Yeah, that's what's worrisome about here is, ostensibly AV security-oriented product. We've seen not even this year, last year as well, VPNs, firewalls, security products being popped. And so these are your security vendors increasing the attack surface for, as Jean put it, all the people in the underworld wearing their hoodies, typing on keyboards at night with green light illuminating their face in a good Matrix way. You can tell I'm in marketing. The other thing, John, Paul had mentioned too, what about going out and, go and find the vulns in the software you're using? Not everybody's equipped to do that. I'm going to say even this year, the AI Cyber Challenge, we're going to see some fun hacking, but I don't think Gen AI is going to start finding things like arbitrary code execution or deserialization bugs in all the software out there. People, however, are still doing that. And John, you found someone that was in software that's close to my heart, in fact.
Yeah, the AIs aren't going to out themselves just quite yet. They want to kill the humans first. But so, and I'm going to give the company a little bit of attention on this because I think their intention was they didn't just find this by accident. So a company, Hidden Layer, they're a startup out there somewhere that's doing security around AI. So with that, I think this is interesting actually. So they found a arbitrary code execution in R, the scientific statistical programming language, which, at least on my radar, I don't know about you might seem like it's still on yours, but it's not quite as much on my radar. Last time I used R was a few years ago when I was tinkering with ML. I think Python and some other things have become more popular. Yeah. But so as a AI security startup, they got their researchers and said, hey, let's go find some. This is me interpreting. They don't say this bluntly in the post, but they said, hey, let's pick one of the AI tools out there, our ML tools, and let's find a vulnerability in there and show what you need to secure your stuff with us. And what's interesting about that is the way it's written, it's clear that they had intention when they went into R, that they were looking for somewhere in there, where could they find something that they could do an exploit? And they found it. So R uses something called RDS, which is their serialized data format. It can be either binary or text. And the article goes through really clearly talking about, it starts with the magic number, it tells you which version it is, and then there's another number after that. They sort of went through and they read the code, and they've done their homework. And they kept going, and they realized that as it goes down that path of deserializing that file, there's chance for remote code execution through several different methods that end up in this file being deserialized. So again, good write-up. It's if you're using R, patch often, patch now. But I thought it was interesting just how does someone, if you're a startup, we've done this in the past. When one of the Run C vulnerabilities came out, I had to go and figure out, okay, well, I need to be able to compromise this. I need to be able to compromise this on stage. I need to be able to go, ooh, that's bad. This is why you need to buy our product. And that's sort of part of the life of a security vendor. But it's interesting to see them actually talk through, without saying all of that, but it's at least to me, it's sort of clear that that's what they were doing.
Yeah, and I like it that aspect that it's, there is the hype of AI, as we talked with Melinda a little bit in the last segment, but it also draws attention for the pen testers, researchers, companies like this. They're just saying, oh, look, there's more software being built. Doesn't matter if it's AI or not. It just so happens that, once again, these APIs are bad, or here is some serialization bugs, or here is a memory safety issue. Here is just a class of vulnerabilities that exists in new software that's being built. So it's kind of where do we focus our attention?
Yeah, and to be clear on there, I'm really not picking on a Hidden Layer. I think that I might not be fully clarifying my interest here. It's Versus if, Paul or I or Mike or whoever, we go out on the weekend and we're like, oh, there's that package on my machine. Let's go and poke around that and see if I find something. It's a very sort of casual thing, and we end up with a blog post out of it and we find something. This feels a little more like I'm going to look at a specific package and keep poking around until I find something. And that takes focus and energy, and it's pretty difficult. And that, at least to me, that sense is what I got off of it. It comes through in the wording, and I thought that was sort of neat.
It is neat, and as you mentioned,
I think Gen AI. I think Gen AI will get better at finding certain problems. I think certainly memory safety and deserialization bugs are probably on the table. I think it's a lot more time before it can find the logic flaws and chain vulnerabilities together that largely now are found by humans. But I think it has the potential to get much better and certainly augment, like John was kind of hinting, it augments, right? I've got all this code to look for, and if I run it through a Gen AI model, it may find certain paths that I can kind of focus on rather than looking at all of the attack surface at once.
Yes, because it's essentially being trained on the, I'll say easy, or the the input validation types of vulns that all these SAS and DAS tools find. So that's what's going to reinforce the Gen AI. It's not being there. There isn't the same wealth of logic flaws and write-ups that Gen AI could be trained on in order to find it. Because as I'm going to continue to repeat for at least throughout 2024, it's still a fancy autocomplete. But speaking of not a logic bug, but a different class of bugs, I did want to pull out again in the spirit of fun written articles about Minecraft. Now, this is if you're running your own Minecraft server, you might be running a version that has some bad random number usage in it. And what I thought was nice about this is there's a little bit of nuance in the sense that certain parts of Minecraft, like many other simulations, do need a deterministic random numbers. They need to, they want to be procedurally generated so that the world can be repeated from a single seed. So it's actually good for that seed to be used, regenerate what the world looks like. It doesn't need to be cryptographically secure. However, there were some areas of the Minecraft code that should have been cryptographically secure, or at least more random, to use the unofficial technical term of art, so that it would blind where users are. Because if you can see where users' locations are within the world, you can go and do nefarious things and figure that out. So it's always fun to see the write-ups that come out of the gaming community and the research there, because it kind of is what John was pointing out with the hidden layer and looking at R, sort of like what within the AI supply chain do we want to poke at, find some vulnerabilities in. Gamers often look at, what's the game I'm playing? Where can I find some vulns? And it is going to take some time and effort to find it typically. And I know John and Paul are working on their Minecraft right now.
It's actually where my mind started going down is a very sort of innocuous phrase at the top, easier for me to say, LLL lattice reduction. And I happened to click on that link, which goes off to a Wikipedia page with way too much nerd on it. But yeah, this is the area where I think you're a little more focused on it than I am, at least on the math side, Mike. But yeah, it's interesting. Lattice has been around. Minecraft has been around for so long and still has a massive following, and people, it's to sort of talk through the use case for some folks who don't know. I have a few friends who are parents, and they don't want their kids playing on the internet. They want to be able to control who's playing with them, so they run their own Minecraft server. And that's sort of where you get into the situation of this. And hopefully that's going to be used just for something as innocent as, let's figure out where Joey is and be able to, manipulate things when he's not around versus something else. So, but yeah.
So yeah, I agree. I think the Minecraft and Roblox, right, are areas where there's a lot of shenanigans online. We've covered stories about that. So people do want to have their own servers. So you probably find more Minecraft servers out there than you would think.
There is another way that I'm going to take you off into the land of nerds, Mr. Kinsella, and Paul can follow along as well. It's been a while since we've covered anything aerospace, but NASA's Voyager 1, or Voyager 1, for those of you who watch Star Trek the Motion Picture, resumes sending engineering updates to Earth. And this is really neat. I admittedly couldn't find a very good AppSec metaphor within here, except for maybe the SRE angle, where NASA engineers have kept this satellite, this little spaceship, online for an amazing amount of time. The other cool thing from this article is just some of the software engineering behind it. Basically, they needed to, a chip failed. They needed to run that code that typically runs on the chip somewhere else, but that code had too much, it needed too much memory. And here, it doesn't say in this particular article, I wanted to find out, but we're probably talking about like maybe 1 kilobyte of memory, maybe 2 kilobytes of memory. We're talking about something that is ancient in internet terms. But what they did was some really fun things that almost looks like some, return. I'm going to stretch my metaphors here, but some ROP techniques, some jumping around in memory. Basically, they took that code, split it into a couple different parts, and then jump between it so the code could still execute. And voila, Voyager 1 is still sending useful radio information. So I thought that was just really neat, really cool software engineering. Caught my eye. Hopefully that entertains our listeners as well.
No, it's neat. I'm glad you threw this in here. It's funny. I was just thinking, the next time I go to brag about the uptime on my server that's, sitting in a cloud or in a data center, just go, hey, dude, how many million miles away is this?
15 billion.
The other thing I was thinking about when you threw this in here was what happens to, I'm sure they're not using it even today, but at some point in the future, these things will go be launching, they'll be using memory safe languages and more modern techniques like that. How do you patch those type of things? So like in a situation like this, right, it's where and obviously we've got so much more resources and everything's grown so many more ways. So this is probably never going to be a problem. But if you ran into a situation where, okay, well, that chip's dead, I need to modify things so it's going to work around it like this, how much of a fight is your language going to give you?
There's going to be that third-party dependency that the signature, was their certificate for it expired and they can't update it.
I would imagine though they take these examples in what the failure was and how they fixed it and re-engineering it into the next launch. So like the next version will probably be like, well, there's some kind of fail-safe. Maybe there's multiple chips in case of a failure or something along those lines. I also thought it was interesting. A lot of the work that we collectively do, we notice a problem and we deploy a fix and we can pretty instantly see if that fix worked or not. In this case, they had to wait 22 and a half hours. So you imagine sitting there for 22 and a half hours going, patience. Does my fix actually work or not, right? And there's a picture of people celebrating, and like you can imagine, we've all worked with software and hardware, for our whole lives pretty much, and that feeling of excitement when you've had to wait that long and your fix actually worked. That's pretty cool.
And it's actually unfortunately it's double that. It's 22 and a half hours each way. So it's actually 42
each way.
hours.
Yeah. Okay. Yeah.
It's like you think your compile times are bad. Yeah, I know it's
right.
Stop complaining. But and Paul made a good comment there too, in the sense that how often does AppSec or InfoSec learn and use this type of engineering feedback? Because to use our metaphors, the national NHT SB, basically the folks looking into airplane crashes, things like that, car crashes. There's a long history of what engineering went wrong. It was only recently we've got the CSRB that's looking at Microsoft, to pick on them for a little bit, saying what went wrong. But I think that's some engineering discipline that we can see a lot more of within InfoSec for sure. I also wish I could see a lot more of John Kinsella and Paul Asadorian, but we've come to the end. So I do have to say thank you. Thank you, John. Thank you, Paul.
Thanks, guys.
As always.
Thanks for everyone who's been joining us. Please do remember to subscribe, share about us on the socials, check out the show notes, and speaking of space, check out Mistakes by Dead Astronauts. We'll see you next time on Application Security Weekly.